Hi friends, this is Vijay Patil, Assistant Professor, Department of Mechanical Engineering, Vivekananda College of Engineering Technology, Puttur. Let us study some of the important concepts of measurement systems and basic concepts of measurement methods. Basically, what do you know by measurement? What you can call measurement? It is nothing but a determination of anything that exists in some amount. That means if you take some objects or any mechanical component, definitely it is having some size and it is having some dimensions, it is having some weight, it is having some thickness, length, breadth, and it is having some density. If you take any fluid, how much quantity of liquid is present in some containers or any tubes or any pipes, and what is the specific gravity of that particular fluid. Oh, that is nothing but some parameters or properties of a particular component is measured through some measuring devices. And that is called as a measurement in general. And if those things are associated with mechanical engineering, then they are called as mechanical measurement. Similarly, if you go for electrical components, some resistor or a capacitance or a inductance of a particular electrical components to be measured, if it is associated with the electrical department or electrical components, then it is called as electrical measurements. Likewise, it is connected with the civil measurements, it may be biological measurements. So many measurement systems are there. But basically, if it is associated with the mechanical components, it is called as a mechanical measurement. The measurement of physical variables and also concerned with their control. That means if you take an engine is connected with some piston cylinders, valves, and flywheels, brake systems, and gearbox systems are there. So every part is connected with some physical variables, and they are under the control. So that control variable to be measured. If you take a brake, what is the torque produced in the rotating disc? If you take an engine, how much of heat is produced? And if you take the oil, how much pressure of oil to be supplied to the engine. So every physical variable of a particular component to be measured in with respect to their control. And accuracy of control is dependent upon the accuracy of measurement. That means how much accurately you can measure the measurement value. That means if you take a brake system, if you apply a brake, how much torque is applied on a rotating disc, that has to be measured. If you take a speed, if you take a speed of a vehicle, that has to be indicated by a speedometer. If you take a digital speedometer, it has to be indicated with the highest accuracy. If you take analog speedometer, it is showing some errors. That means it is nearer to the value, but there are some errors. That means the accuracy of a control is dependent upon the accuracy of measurement. That means if you are going to measure the measurement value with the highest accuracy, so that can be controlled with the highest precision. Next, let us see what is the basic process of measurement. The process or act of obtaining a quantitative comparison between the predefined standard and unknown magnitude. That means if you are going to measure a length of any component, you can measure with the help of a scale, or you can measure with the help of a vernier caliper, or you can use some measuring devices like micrometers and all. So they are called as a standards. That means standard is nothing but something which is set up as a uh, predefined or a standard for measuring the unknown magnitude. So if you are going to measure any length of a particular mechanical components, you can use the scale. So scale is nothing but a standard. It is having some millimeters, centimeters, or it is having some inches or foots or yards. So these measuring values are set as a standards. With reference to the standards, we are going to measure the unknown magnitude. If you see this diagram, there is one process or a comparison element is there. That measure value to be defined. That is nothing but it is nothing but a measurand. That means measurand means the value which has to be measured. It is nothing but a measurand. And how that is measured? So that can be measured with the help of a standard measuring device or a standard measuring element like scales, vernier calipers, protractors for measuring the angles, or sign centers, sign bars, as you have studied in previous modules. So there are so many measuring instruments are there. Using them, you can measure the unknown magnitude. That is called as a standard. Using the standard, you can measure the unknown magnitude. And finally, you're going to get the result. That means how much value you have measured, that can be indicated with the analog scales or digital scales or some digital displays. So the result may be, it may be a temperature, it may be a velocity, it may be acceleration, it may be related to the dimensions of a particular mechanical component like length, width, thickness, density. If you take fluids, it may be related to some density, surface tension, specific gravity, and a specific volume, specific weight, and the finally whatever the output you are going to get, that is nothing but a result of a particular measured value. Next, let us see. So as I told, in measurement there are different parameters are there, like a measurement. That means whichever the property or a variable to be measured with the help of standard, it's called as a measurement. So if you take a physical quantity or any mechanical property like length, angle, width, thickness, it is nothing but a measurement. So similarly, if it is related to fluids, as I told, some fluid properties are going to be measured, and it may be a temperature also. So basically the properties or variables of a particular component which is to be measured is nothing but a measurement. So how we are going to measure the values or a particular property of a material? With the help of a standard one. That is nothing but the standard measuring element is there. So with reference to that one, we are going to compare the value to be measured. So for that comparison or a comparator, we are going to use some measuring instruments or standard elements. And going to the reference, the physical quantity or proper to which quantitative measures are made. That means whatever the standard measuring instruments you are going to use, that we are going to keep it as a reference. So usually there are different standards are there, primary standards, secondary standards, ternary standards, and working standards. So primary standards are nothing but they are kept under certain security conditions. That means whenever there are alterations in the secondary measuring instruments, in order to calibrate that one, we are going to use the primary standard. And coming to the ternary standards, suppose if any vernier, if you take a vernier caliper or a vernier height gauge or a bevel protector, some errors are there in that particular instrument. So in order to calibrate it or in order to make it correct, in order to make it used for a correct measurement, so in order to calibrate that one, we are going to measure the we are going to refer the secondary standards. So that means using the standards, we are going to calibrate or correct the errored measuring instruments. And next we will see, as I told, there are standards are there. Standards are nothing but they are used for the reference one. That means in order to correct the measuring instruments, we are going to use them. And there are some gauges you studied in first and second modules. There are various gauges are there: snap gauge, go gauge, no go gauge. In order to check the dimensions, they are usually used in the quality control departments. So these plug gauges, snap gauges, go gauge, no go gauge, so these are used to check the dimensions or position of a product features of manufactured components. And measuring instruments, so we have studied there are measurement, there is a process which involves the processing of the input and which will give the output through the some measuring instruments. So basically what you can call as a measuring instrument. If you want to weigh some mechanical components, so that component you are going to place in a weighing machine, right? So that will give the weight of a particular component in terms of grams, in terms of milligrams, in terms of kilograms. So if you take length, if you are going to measure the scales, vernier calipers, vernier height gauge, bevel protectors, so the basic physical property of a material, it has to be measured. With what? With what is nothing but using some standard measuring devices that are nothing but measuring instruments. So measuring instruments, there are different types of measuring instruments are there, like if you want to measure the physical properties like length, mass, time, and angles, there are some instruments are there. If you want to measure the viscosity, flow properties, temperature aspects, and if you want to measure the torque, so for that one there are different measuring instruments are there. So measuring instruments are maybe in analog systems, or it may be in a digital form also. And basically, coming to the measurement, if you want to measure the physical measurement, so there is a basic size of a particular component. That means if you take a shaft, mechanical shaft, there is a basic size. If you want to manufacture the diameter of a shaft with 25 mm, so 25 mm is a basic size. Upon that one, you can keep the tolerance. Tolerance is more what, in order to get the clearance fit or a interference fit or a transition fit or a freeze fit based upon our requirement in assembly. So we are going to keep some tolerances. So as you studied in fits and limits and tolerances, so you know what is true size and actual size and exact size. A true size is nothing but a theoretical size of a dimension which is free from errors of a measurement. That means there is no errors. Exact dimension of a component is present. That is nothing but a true size. And actual size is nothing but is a value of size obtained through the measurement with permissible measuring error. That means if you take some digital vernier caliper and manual conventional vernier caliper, so if the worker or person who is going to measure the component, so if it is not accurate, then you are going to get some errors. So if he is not skilled enough, there are chances of getting some errors. But he has measured some actual size of a component. But if you take a digital vernier caliper, even though unskilled labor, if he place the digital vernier caliper, it will give the exact size. That means whenever there is a permissible error due to some measuring errors, or it may be due to some worker measuring skills, we are going to get some errors. It may be a human error, it may be an instrumental error, it may be internal errors. So you are going to get some exact size nearer to the actual value. It is nothing but actual size, but there are some errors are present. And exact size is nothing but the value of size obtained with the highest metrological accuracy attained in a practice. That means if you take a valve measuring instruments are there, or any tooth thickness measuring instruments are there, or if you want to measure the gear module or gate thickness, so you are going to use some measuring instruments. So how many teeth are there, what is the pitch between the two teeth, or what is the tooth thickness, what is the model of a thickness. So for that one, gear tooth vernier caliper you are going to use. So at that time we are going to get the exact size. If you miss the exact size, so two gears are not going to meet exactly. There is a slip between the two gears. So in order to get the correct assembly or correct smooth working conditions mechanical components, so we have to get the exact sizes. That means so that much accurate measuring instruments we need. Coming to the approximate size, so if you are a design engineer, so in order to design some components, so before going to the basic size or exact size, you have to keep some approximate size. And using some calculations or a trial and error method, we are going to get the exact sizes. So basically, what is the approximate size? It's a value of size obtained with the error exceeding permissible error of measurement or requiring refinement. That means, and if you take the machining also, if you want to manufacture one component, so through the casting we will get one size, and we are going to machine it to get to the exact size. That means approximately we are going to manufacture the product through the casting, then we are going to machine it to the exact size. So previously what happened, if you cast to the exact size particular mechanical component, if you want to make some alteration, it is not possible after machining. So in order to avoid that one, so previously we are going to keep the approximate size, then we are going to machine it to the exact size. So for that one, approximate size is very important. And error of measurement, what do you mean by error? Error is in simple terms, so it is a difference between the exact value and the measured value of a particular parameter. Suppose If the bike is running at 80 kilometers per hour, the speedometer is giving 70 kilometers per hour, that 10 kilometer is a error. That means that much difference is there between the exact value as well as measured value. That is nothing but error. And errors are due to some internal disturbance, or due to the some misalignments between the two components in measuring instruments. It may be due to some long over usage, that instrument is not calibrated properly, and it may be due to some human errors, some contact errors also. So the different types of errors are there. Error is nothing but it is a value which is measured and a value which is previously found. It is a difference between the measured value as well as exact value. And correction, correction is nothing but in order to overcome the error, so whatever the difference is there, that we are going to calibrate it to get the exact measuring value. That is nothing but the correction which is amount should be algebraically added to the indicated value to obtain the actual value. That means whatever the difference we are going to get, that we are going to correct it. And that is nothing but calibration means in order to overcome the errors in the instrument, we are going to use the standard measuring devices as a reference. With the reference to that standard, we are going to correct the working measuring instrument. And coming to requirements of measurement, what is the primary requirement for a measurement? Why we need to do the measurement? So first thing, a standard used for a comparison must be accurately known and commonly accepted. That means if you want to measure any length of a particular component, usually we know that length of a particular component is measured in centimeter, millimeter, or meters, right? Or it may be in inches, or it may be in yards, or it may be in foots. So this is known across the world. That means it is universal standard. That means if you want to measure any length, so various parameters like meters, kilometers, millimeters, centimeters, yards, inches, foots, and kilometers. So these parameters are common across the world. That means so whichever the component or whichever the parameter or whichever the physical thing to be measured, that has to be known, and the measuring parameter should be known common to the world. That means it is common across the world. And second one, the procedure and apparatus used for a comparison must be commonly accepted and must be provable. That means whatever the measuring method is there, or our measuring instruments are there, that has to be accepted common across the world. That means if you want to measure the particular angle, so we can use the bevel protractor, or you can use the protractors, different type of protractors, or it may be you may use some angle measuring instruments. So using that one, we can go for a measurements. Likewise, if you want to measure the gear tooth thickness, we are going to use the gear tooth vernier calipers and bevel protractors. And if you want to measure the any fluid viscosity, density, various instruments are there. If you want to measure the fluid properties, like whatever the pressure is there, velocity is there, so venturimeter, orifice meter, and Bourdon tubes are there. And if you want to measure the torques, so some brake measuring instruments, brake drums, and torque measuring instruments are there. Dynamometers are there. So these measuring instruments are common across the world. They are made as a common. That means it is universally accepted. Significance of a measurement. Coming to the significance, the fundamental basis for research and development. That means why we need to measure the particular components. So fundamental basis is related to the basically the research and development. That means whichever the products coming out of the market, and that has to be processed or manufactured with the highest accuracy. That means so much of research and development, trial and error methods are gone previous to the manufacturing, and research team going to carry out what is the basic size to be kept, and they are going to consider the ergonomic aspects. After manufacturing the component, it has to be user friendly. It has to be used by all type of industries, and it is user friendly. So they are going to consider some ergonomic aspects, and they are going to carry out such and development. It is to be cost effective. So all these are going to contribute for the research and development. So in research and development, the measurement is very important. Second thing, it facilitates easy performance. That means if you take pipes, different types of pipes are there. It may be bent, it may be a contract one, it may be enlarged one. Now to cater the different types of elements, and the measured value to be known to the workers or humans. That means if you go to the shop, if you ask for a pipe, so what is the parameter you are going to tell him? Directly you cannot tell him go give one pipe. So you have to tell the exact dimension of a pipe. That means half inch, the 3 by 4 inch, or 1 inch, 2 inch, 3 inch. So that dimension to be known by a person. That means it facilitates easy performance. That means it is universally accepted that measured value, if you tell, that component can be given easily. That means the measurement plays very important for a easy performance. That means day to day life, if you know the measurement, if you know the measured value of a particular components, it is easy to manufacture, easy to sold in a market. And fundamental element of any control process. That means measurement is a fundamental element for any control process. So in order to control the any mechanical component or any mechanical part or any mechanism, so various parameter of that particular mechanism to be known. If you take a IC engine, what is the heat produced and what is the uh, heating and cooling rate inside and outside the engine, and what is the fluid flow properties and oil pressures, and what is the torque produced by a flywheel, and what is the thermal properties of a particular engine components. So that is nothing but it is a fundamental element. That means measurement is a fundamental element for controlling any mechanical process. And fourth one, basis of commerce in terms of cost, material, power, expenditure, and time, labor. That means if you know the measurement, if you want to manufacture an exact dimension of a mechanical component, you are going to calculate what is the cost involved in it, how much time is involved in it, and what is the manpower required for that manufacturing of a component. So all these things come into picture while you are in a production. That means in order to carry out these all these aspects, basically the measurement plays a very important role. Without measurement, you cannot manufacture any mechanical component. You cannot calculate what is the cost involved in it and how much time it will take to manufacture a particular component. So for that one, so measurement plays a very important role. First one, it plays very important role in research and development. It is used for easy performance, and it is used in a control process, and finally it is going to use help in a cost, material, power, expenditure, and time, labor. Next we will see how the fundamental methods of measurements are available in the market. That means how the measurement is being done. That means as I told, usually we are going to compare the measurement with the standard value. That means as I told, in the standards there are primary standards or secondary standards. Primary standards are usually they are in research laboratories. They are kept as a highest reference value. That means they are going to come in first. Second, there are secondary standards. Third one, tertiary standards, and finally there are working standards. That means in order to measure some physical value or any parameter, so we are going to compare that measurement value with the reference. That means standard. That is nothing but direct comparison between the standard as well as the measurement being done. And second one, indirect comparison through use of calibrated system. That means whichever the calibrated system is there. If you take a weighing machine, so weighing machine is calibrated previously. That means if you going to put some weight stones of 1 kg, 2 kg, half kg, or 3 kgs, it is going to give the exact value. That means the previously it is calibrated to that value. That means whatever the weight you are going to put, that is going to show. That means that instrument is previously calibrated. That means it is indirect comparison. That means the whatever the calibrated instrument is there or any device is there, through that one you are going to measure the physical property of a mechanical component. And direct comparison with primary and secondary standards. If you take primary standards, so primary standards are nothing but all the measuring instruments, vernier caliper, protractors, and temperature measuring thermometers. It may be a conventional thermometer or it may be a digital thermometer, and fluid flow measuring devices, notches, venturometer, RFIs meters, pitot tubes, and some pressure measuring instrument like board-on tubes. So many instruments are there. They are acting as a standard one. With reference to that one, you are going to compare the measurement value. And direct comparison, that means due to some human sense or human errors, there are some chances of getting the errors. That means accuracy is not that much high. Hence, scientific and research work in this method is not suitable. That means direct comparison with primary and second standards is not suitable for a research work. That means there are some chances of getting the errors. So that's why we are going to use the calibrated systems to measure the physical measurements physical parameters of components. In calibrated system, measurement is done with the help of a chain of devices. As I told, there is a calibrated system or a calibrated mechanism or a calibrated device is there. With reference to that one, we are going to measure the physical parameters. A chain of devices transform a sensed signal into a more convenient form and indicate this transformed signal either on an indicator or recorded or fed into a controller. That means if you take a digital speedometer, so as you give a throttle to accelerator, you are going to get some accurate speed of a vehicle. That means at what speed the wheel is running. That means there is a sensor, there is a signal transformation unit is there, and that transform unit is controlled by using some controller, PID controller, or fuzzy logic systems. Various controllers are there, proportional controllers, integral controllers, and different controllers are there. Using that controller, the value is controlled, and we are going to get the accurate output through some binary signals. Finally, the binary signal is indicated through the digital display. That means there is a calibrated system, series of chains of parts are there. It may be mechanical or electrical. Together, it is a mechatronic system will be there, and it is calibrated earlier. And through that one, we are going to get the accurate dimensions or accurate parameters like length, mass, time, density, or any flow parameter or a temperature parameters are there. So we are going to get the exact output, exact precise value we are going to get. So the in between, in order to get the amplification, if you are measuring the uh, flank between the two threads, so we are going to keep the bolt on a what you can call the measuring instrument. So in order to magnify it, there is an amplification unit, there is a magnification lenses are there. So using that magnification lens, we are going to get the what is the flank between the two threads, and what is the inclination between the two threads, and what is the pitch thickness. So that we are going to measure with the help of amplification. And filtering means if you want to measure some vibration concepts or vibration parameters in mechanical components. So in a suspension system, there is a coil spring will be there in order to get some vibration signal. So there is an unwanted thing. That means nothing but there is a disturbance. If you take voice signal, in voice there is some disturbance. That means unwanted sound is there. In order to filter that one, we are going to use the filters, mechanical filter, electrical filter, sound filters are there, and noise filters are there. So various filter, with help of various filters, you are going to measure we are going to avoid the unwanted things. That is nothing but we are going to remove the errors. And using this indirect comparison, we are going to get the precise value. That's why this system is usually used in Commonly it is used in order to get the exact values. Uh, Coming to the precise and accuracy, this picture depicts that in first picture you can see three arrows are placed on a outer circle. That means you can see if you want to throw the arrows on a center red marked circle at the center. So if you see the first picture, the arrows are placed randomly. That means you can see there is a low accuracy and low precision. That means there is no accuracy. If you want to place those arrows in a smaller circle, in a red circle, there is no accuracy. All are placed in outer circle. There is no accuracy and there is no precision. And second, you can see low accuracy and high precision. That means what? What is what you can call as a accuracy and precision? That means in the second picture you can see all three arrows are nearer. That means you have thrown the arrows very nearer points or exact point. That means precisely they are placed or emerged into a particular point, but there is no accuracy. Our point is to place the all arrows in a red circle. That means there is no accuracy, but precisely they are placed to a particular point. If you take the third point, high accuracy and low precision, that means all the three arrows are nearer to the red circle. That means accurately you have thrown the arrows, but there is no precise value. That means they are not emerged into a precise point or exact point. And if you see the fourth figure, all the arrows are placed in a red circle and at a particular center point. That means there is a high accuracy there and they are placed or emerged into a center point with the highest exact value. That is nothing but precision. So this is the major difference between the precision and accuracy. That means precision is nothing but it involves accuracy as well as it is going to give the exact answer or exact measurement to be done. Accuracy is nothing but you are going to get the correct output every time, but that output is not exactly nearer to the measurement to be done, actual measurement to be done. This is the major difference between the precision and accuracy. In this picture you can figure out how the precision and accuracy, and this is a comparison. As I told, accuracy and precision, accuracy is commonly it is a closeness with which true value of a quantity being measured, and precision is it is a measure of a reproducibility of a measurement. That means every time you are going to get the exact value. Usually in a measuring instrument, so this is the primary desirable characteristic required for any measuring instrument. Precise, it is should give the precise values every time. And second point, accuracy of measurement means conformity to the truth. And precision, the term precise means clearly or sharply defined. That means sharply or clearly it is done. That means precisely it is going to give the values. Exactness, that means precise is nothing but exactness. For this one, if you take any runner, fast runner, usually if a fast runner is going to complete the 100 meters track with suppose for example if you take 8 seconds, so every time he is not going to finish with 8 seconds. Sometimes he may take 8.3 seconds, 8.4 seconds, or he may take 7.99 seconds, some milliseconds also. That means accurately he is nearer to the exact seconds, that means the exact finishing point, but he is not precise. But if the man or a runner is going to finish the track with the same finishing time, that means if we consider 8.1 second, every time he is going to finish the track with the 8.1 second, that means he is accurate and precise runner. That means every time he is going to finish the track at an exact time, that is nothing but precise. um, and fourth point, third point is nothing but accuracy can be improved. That means every time you can improve the accuracy, and precision cannot be improved. That precision is nothing but is a one time. If you are going to get the exact value, exact desired value, that is nothing but precise. If the instrument is precise, no need to calibrate it again. But if accuracy is there in an instrument but precision is not there, then we can calibrate it and bring it nearer to the precise value. And fourth point, accuracy depends upon a simple techniques of analysis, and here precision depends upon many factors, requires many sophisticated techniques of analysis. That means if you take a suspension system, if you take a leaf spring, if you take a coil spring, there is a lot of difference. In a leaf spring you are going to get so much of vibration, the suspension is not that much smooth. But if you take a coil spring, you are going to get highest suspension value. That means you are going to get a riding comfort. There are no undesired vibrations produced while the vehicle is under motion. So likewise, there are some dampers are there, magnetological dampers and electromagnetic dampers are there. So many dampers are there, so many suspension systems are there, self excitation and self controlled, so suspension systems are there. So that means if you go for a sophisticated analysis techniques or sophisticated instruments, sophisticated methods, you are going to get a precise value or a precise smoothness in a quantity being measured. And fifth one, accuracy is not necessary but sufficient condition for a precision. That means, as I told, precision involves accuracy as well as the exactness. That means without accuracy we cannot go for the precision. That means accuracy, the exactness or closeness value will be there, but we are not able to reach the exactness. So that can be achieved through the precision. That means without the accuracy, precision will not come into picture. Let us coming to the calibration. Calibration is a comparison between the measurement of known magnitude. That means uh, known magnitude is nothing but it's a standard one. As I told, the standard instruments are there, or standard reference devices are there. With reference to that reference or a standard one, we are going to calibrate the known magnitude. That means if you go to the petrol bunks, the petrol bunk is not discharging the fuel with the highest accuracy. That means if you want to place 1 liter of petrol in a bottle, it is going to give only 980 ml of petrol. That means the 20 ml difference is there. So that means that instrument is not working properly. It needs a calibration. Calibration is nothing but the comparison between the reference as well as measurement being done. That means whatever the magnitude is there, that is compared with the reference one, and we are going to remove the error, remove the difference between the exact value as well as measured value. And using calibration, we are going to get the exact output or a close output. And in order to calibrate or in order to do the calibration, we need some devices. And device with which known or assigned correctness is nothing but standard. That means, as I told, standards are going to play a very important role in calibration. And second device is unit under test. Unit under test or test instrument. That means whatever the device we are going to take as standards, they are classified under the UUT as well as the test instrument. The test instruments or calibrated instruments are going to play a role as a reference one. With reference to them, we are going to remove the errors, and we are going to calibrate the instruments. And before going to the calibration or calibrating instruments, we will see some important aspects of measuring devices. Whatever the instrument you are going to see in this picture is it is a digital vernier caliper. You can see 29.70 mm, that is a measurement of one screw. You can see in the picture length of screw. If you take a conventional vernier caliper, there are chances of getting some errors. If the measurer or a person who is going to measure it, if he is not skilled enough, if he is not going to measure the main scale division, vernier scale divisions, if you miss some vernier scale divisions, you are going to get some errors. So that means due to some readability error, that value is not measured properly. So what you can call it as a readability? How the readability is defined? The ease with which the readings of a measurement instrument can be read. That means how much easily you can read the measured value. That means you can easily use easily read the value. That means 29.70. But in conventional, you have to count main scale division, 1 year scale division. You have to calculate. Then you have to come into conclusion to the exact value. It means ease with which or how easily you can measure the value. That is nothing but readability. If you take a weighing pan or weighing machine, if you stand at a weighing machine, it is going to use some weight, 73 kg, 69 kg, 55 kgs. So using some needles, a conventional type of measuring techniques, easily you can read. If you take a digital weighing machine also, it is going to give in a digital form. That means any instrument, it should be having some readability property. That means the user should be read the measured value with the highest easiness, or it is having some uh, easy property to read the measured value. And you can see some display panel, usually you can see in the cars and all. So you can see the first meter is showing rpm of engine, and second one seeing how much uh, heat is present in the engine, and what is the degree of coolness or hotness that it is going to measure. And third meter is going to show the fuel, how much fuel is there in the tank, whether it is empty, whether it is half, whether it is full. That you can easily use it. Even the uneducated fellow, the unskilled fellow can read it. That means any instrument which is to be designed, that has to be designed with the highest easiness of readability. That means any person can read it. And similarly, the fourth meter is showing speedometer. That means what is the speed of a vehicle, at which speed it is going to um, moving, at which speed it is going to run, that is measured. And the display, basically this picture or a display, you can see all the meters you can easily read. That means it is nothing but the easiness with which you can read the value, that is nothing but readability. And least count, you know already what is the least count. That means the lowest value with which the lowest value you can measure, the lowest value that can be measured on any instrument, it is nothing but a least count or a least value that can be measured. Least count, if you take a scale, what is the least value that, if you take a normal scale, centimeter scale, it may be a 15 centimeter scale or 30 centimeter scale. If you see between 0 to 1 centimeter, there are some 10 divisions are there. That means the smallest value that can be measured on a normal scale is nothing but 1 mm. That means using some divisions, you can measure the least value, the least value on an instrument that can be measured. Similarly, we can define least count of any instrument, that is nothing but smallest quantity that can be measured accurately using that instrument, that is nothing but a least count. In figure you can see the micrometer as well as vernier caliper. The least count is basically defined with the smallest main scale division divided by total number of vernier scale divisions. If you take vernier caliper, the least count of vernier caliper is 0.02 mm. That means there is a one main scale division divided by 50 number of linear divisions are there on a vernier scale. 1 by 50 you will get 0.02. That means the least value of vernier caliper is 0.02 mm. Similarly, if you take micrometer, micrometer is having 0.01 mm as a least count. Similarly, all the instruments having a least count, and basically least count is nothing but the smallest value that can be measured with the highest accuracy is nothing but least count. And range, what is a range? Coming to the range, if you take any measuring instrument or a measuring scale, if you take a weighing pan, or any speedometer. If you see the speedometer in the cars, usually some meters are 0 to 180 kilometers is the range, or 0 to 220 kilometers is the range. If you take some sophisticated cars, those cars which are running at higher speeds like BMW, Jaguar and all, they are having 0 to 500 kilometers range, or 0 to 350 kilometers range. That means from 0 to that highest value, between those, what is the difference is that is nothing but a range. It is a minimum capacity or a maximum capacity uh, of a value that is measured by a particular instrument. Is nothing but a range of an instrument, how much value it can measure, and that is nothing but range. If you take a micrometer, usually the micrometer what you are seeing in a measurement and metrology lab, it is having 0 to 25 mm measuring capacity. That means 25 mm is the last value that can be measured by that particular instrument. That is nothing but a range. The range is varying from minimum to the maximum value. Minimum is the least value that can be measured, and maximum is the highest value that can be measured by a particular measuring instrument. That is nothing but range. Definition says that measuring range is minimum capacity and maximum capacity that can be measured by a instrument. Basically, in general, you can take range is nothing but a minimum and maximum value that can be measured by a particular instrument. And as I told, this is a RPM indicator, RPM measuring meter. The lowest value start from 0 and highest value ends with 11 into 1000 RPM. That means highest value that is measured by this RPM indicator is nothing but 11,000 RPM. That means revolutions per minute. How much RPM the engine is having, that is measured. Highest value is 11,000 RPM. This is the range of this measuring meter or measuring instrument. And let us see the true value and accurate value in the next class, or next video. I will discuss what is the true value and actual value. And stay home, stay safe, and bye bye. Thank you.